Okay, hi everyone. So first thing, this video is optional, so if you don't want to watch it, you don't have to. It is just going to be going through some extra examples of straight line equation stuff. So the first sort of question I'm going to go through is finding the equation of the line from a diagram. So I didn't spend ages on this because you will have seen it at some point earlier in the year, but I'm going to go over this one just as an extra one. So when we've got a straight line, they're always in the form y equals mx plus c. So in this form, m represents the gradient or the steepness of the line, and c, that is the y-intercept, so that is where the line crosses the y-axis. So when we've got our form here, we need to fill in basically what m and c are. So let's do c first because that's a little bit easier. So the y-intercept, that's where the line crosses the y-axis. So looking at our diagram here, where does the line cross the y-axis? So got our y-axis here, so the line crosses it at 1. So what that tells us, c is 1. So we can fill that in now. So we've got y equals mx. Instead of plus c, we can just have plus 1 because we know what c is now. So we still don't have the gradient though, so we need to work that out. So how do we work out the gradient? We pick 2 points on the line, and if you can, try and pick ones that line up nicely with the grid points. I'm going to pick these two. And then we draw a line to represent the change in the x value. So in this case it's changed by 1. We draw a line to represent the change in the y value. So in this case it's gone from 1 to 3, so that's a change of 2. With the x it's gone from 0 to 1, so that's a change of 1. So the gradient, or m, that equals the change in y divided by the change in x. So you can pick any 2 points on the line, you'll always get the same answer. So in this case though, we've got a change in y is 2, change in x is 1, so our gradient is just 2. So finally we can write our line equation, y equals 2x plus 1, and there is our answer. Okay, so a bit about parallel lines now as well. So what we need to do, question saying what is the gradient of a line parallel to line L? So we've got line L here, we need to work out what the gradient is of a line parallel to it. So parallel lines always have the same gradient as each other. So if we have a line that's parallel to L, that means it's got the same gradient. So if we can work out the gradient of L, then we know the gradient of a line that's parallel to L. So like what we did before when we're looking at the gradient, we're going to do it by doing, so I'll write over here first, m, or the gradient, that is change y over change in x. So change in y divided by change in x. So let's draw some lines to represent that. So again, I've picked 2 points deliberately that line up nice with the grid, it makes it a bit easier. So the change in y, that's changed by 1. Change in x is changed by 2. So that gives us 1 over 2. So the gradient is a half. So give an example of a line parallel to L. So line equations we've said is y equals mx plus c. So we know our m has got to be the same, so our gradient has got to be the same as the gradient of L. So we know that m is going to be a half. So it's y equals a half x plus c. And any line that has the gradient of a half is going to be parallel to L. So c can be any value. So some examples you could do for the second question is y equals a half x. That's fine, that just passes through the origin, but it's parallel to L. You could have y equals a half x plus anything. So half x plus 1. You can have y equals half x minus 10. So as long as it's y equals half x and then plus or minus something, it will always be parallel to L. If you want to check that, have a look on Desmos online and you can plot different graphs and check, and you can see that if they've got the same gradient, they are parallel. Okay, so last example, a little bit tricky because it's perpendicular lines, so bear in mind this is an extension topic, so this isn't actually on your scheme of work for this year. This is a bit beyond where you need to do. So you will be seeing more of these next year, so if you do crack it this year, excellent, you'll find next year a bit easier. If you don't worry too much, you will see it again next year anyway. So what is the gradient of a line perpendicular to line L? So with this one, we're going to start out, we need to know what the gradient of L is still. So we're going to start off by working out gradient of L. Because to work out the gradient of one that's perpendicular to L, we need to first know the gradient of L. So again, pick two grid lines, 2 points on the line that are on grid lines, right? So then we've got a change in x, a change in y. So change in y is 1, change in x is 2. So gradient of, so that's, I'm just going to write delta y to represent change in y and change in x. So change in y is 1, change in x is 2. So that's just a half, don't need to write an equals there. So we've got our gradient of L. So now, to work out the gradient of a line perpendicular to L, like with the parallel lines where there's a rule, with perpendicular lines there's a rule as well, and it's that the gradient of the two lines multiplies to make minus 1. So we've got our gradient of L. So basically I'll write out our rule as m1 times m2. So this is gradient of line 1. So in this case line 1 will use L. And gradient of line 2. So gradient of line 1 times gradient of line 2 equals minus 1. So if we're saying line 1 is L, that means m1, that is a half. So we've got a half times m2 equals minus 1. So now that we've got that, we can solve this and work out what m2 is. So that'll be the gradient of the line perpendicular to line L, which is what we want here. So if a half of m2 is minus 1, if we times both sides by 2, that gets rid of the half on the left, so we're just left with m2 equals minus 2. So our gradient of a line perpendicular is minus 2. So every perpendicular line to L would have a gradient of minus 2. Again, if you want to check little Desmos, you can plot one that's got a gradient of a half, plot one that's got a gradient of minus 2, and you'll be able to check that they are perpendicular. So now, for the second part, it's saying give us an example of a line perpendicular to L. So we've got y equals mx plus c. And we know that to be perpendicular to L, it has to have a gradient of minus 2. So it's going to be y equals minus 2x plus c. So again, like the one before, we can have any line with a gradient minus 2. So we could have y equals minus 2x and then have 0 c, so it'd just be y equals minus 2x. You could have y equals minus 2x minus 100, or you could have y equals minus 2x plus 10. So basically any line that has a gradient of minus 2 will be perpendicular to L, because the gradients will multiply to make minus 1. So this is a really useful rule, but it's not one you need at the moment. It's just one that it's good to know because it'll make your life easier next year. So yeah, again, feel free to email if you've got any questions. Yeah, hopefully these have helped a bit.